Hello guys, in this video we're going to talk about complex numbers. In our previous video we talked about addition and subtraction of complex numbers. In this video we're going to talk about argument and modulus of a complex number. First thing first, let's recall what a complex number is. Now, a complex number is any number of the form z equal to a plus bi, where a and b are real numbers, and the I here, this I here is the imaginary unit with the property. So the I here is the imaginary unit, and it is with the property of I squared equal to -1. That's what we have. Now, so in this complex number here, the A here, the A in the complex number is the real part of the complex number. That's the Z. And the B is the imaginary part of the complex number. Z here. So if you have a complex number like Z equal to 3 plus 4i, now our A here is the real part of the complex number, and the 4 here is the B, which is the imaginary part of the complex number. Now let's talk about the modulus of a complex number. The modulus of a complex number is a measure of the distance from the origin to the point represented by the complex number in the complex plane. So let's say this is our complex plane here, right? And we have this graph here. So on this graph we have a complex number represented. So this is our complex number represented. So what is the modulus of a complex number? And what I'm saying is the distance that form from the origin to the point represented by the complex number, and this is the complex number. So this distance from here, this is the origin of the plane to this point. So the modulus of a complex number is this distance here. So how do we find the modulus of this complex number? Now let's go back with this form. So let's say this right angle triangle. Now we know this value. This value is the B, and this value is the A. How do we find this part? So this right angle triangle, right? So how do we find this C part? And this C part is the Z part of the complex number, and this are modulus of the complex number. So modulus of this complex number is gonna be the square root of A squared plus B squared. This can also be denoted by this. So the modulus of the complex number equal to the square root of A squared plus B squared. Sometimes the question can also be given to you in this form. Like they'll give you the question like maybe Z equal to 3 plus 4i, and they'll put the question like find the complex number of A plus bi here. It's the same as the modulus of the complex number. So with the same format you go with the complex number of A plus bi is equal to the square root of A squared plus B squared. It can also be given to you in this form. When they ask you to find this, is the same as the modulus of the complex number, which is the same as A squared plus B squared. So let's take an example. So let's say we have a complex number Z equal to 3 plus 4i. Let's find the modulus of this complex number. So we simply put the modulus of complex number is equal to the square root of A squared plus B squared, where our A is 3, B here is 4. So when we put into this equation here, we have 3 squared plus 4 squared, which we get 25 squared. Square root of 25 is 5 here. So that's simply the modulus of a complex number. Very, very simple, right? Now, let's go to the argument of a complex number. The argument of a complex number. So, with the argument of a complex number, let's take a close look at the argument of a complex number. So, the argument of a complex number z, represented here, right? A plus bi is the angle formed between the positive real axis. So this is the positive real axis. This is the real axis here, right? And the line representing the complex number. This is the line representing the complex number. So the angle forming between these two lines here, the line representing the complex number and the real axis, the positive real axis here, is the angle that we are talking about, which is the argument of a complex number, which is theta. Right. Now, mathematically, the argument of a complex number, which is arg of z, which is the complex number, is theta. That theta here should be equal to arg z, equal to the tan inverse of b over a, right? So we have a here and we have b here. So the angle that makes between these two lines is what we are looking for. Now, here we know that the a is the real part and the b is the imaginary part of a plus bi. But remember, this formula gives us the principal value of the argument, which lies between negative pi and pi, which is positive pi, right? Radians, right? Also known as like 180 degrees and positive 180 degrees, right? This is what it gives us. This is very restricted value that we are going to find our angles between these two, or within these two values given to us. So what we have to do now is, let's see how to determine the argument in each of the four quadrants. So with the first quadrant, let's say I have this plane here, right? So in the first quadrant, whenever you're having a, so this are, you know that this is our first quadrant. So let's draw our line here. And this is our complex number a plus bi. And we have our a to be positive and b to be also positive. So in the first quadrant, a should be greater than 0 and b should be also greater than 0. So here both a and b are positive. So the angle is simply theta is equal to tan inverse of b over a. That's within our first quadrant. So this is the first quadrant. Right? So let's say this is our second quadrant. Now, second quadrant, we come back to this part. So we have our complex number here, z equal to. So here our a is going to be negative and our b is going to be positive, right? So we have our a here negative, our b here positive. So in this we have a less than 0 and b greater than 0 here. So in this quadrant, a is negative and b is positive. So the angle here is simply theta is equal to pi plus tan inverse of b over a. Very simple. Now, let's go to our third quadrant. How do we find the angle in the third quadrant? So in our third quadrant, we have the line here. We have the complex number here, right? So in this quadrant, we have both a and b to be negative. So let's draw a line here. So B is negative, A is negative, angle is here, right? So simply we have it to be so here we have A less than 0, B less than 0. So simply theta is gonna be negative pi plus tan inverse of B over A. Very simple. Very simple. So this is our third quadrant. Finally, in our final part, which is the fourth quadrant. So how do we find the angle in the fourth quadrant? So in our fourth quadrant, we have the complex number here, which the B is going to be negative and the A is going to be positive. So A plus negative, so let's say negative, so negative BI, right? So let's redraw it from here, A here, B here, right? So in here we have A greater than 0, B less than 0. So simply our theta is going to be tan inverse of B over A. So here the angle is going to be negative. So negative of the angle, like the angle that you get. So negative angle here. So any number that you get just is negative. That's it is in the fourth quadrant. Okay. Now let's take some examples. So in our first example, we have the complex number here, z equal to 1 plus I, right? So let's find the argument of it. So what is the argument of this? So here we know that our A here is 1, our B2 is 1, right? Then, and when we draw our agar diagram here, we know that when we plot this, we are going to have both to be in the first quadrant. So let's say it's right here. One plus I, right? So angle is gonna be here. Then we have our argument, which is arg z or theta. So tan inverse of B over A. So tan inverse of our B is what? 1, and our A is also 1. So 1 over 1, simply 1. So the tan inverse of 1 is 45 degrees. Also as pi on 4 radians. So the argument of z, which is 1 plus I, is 45 degrees or pi on 4 radians. Very simple. Let's go to our second example. You can pause this video and try to do it on your own. So in our second example, we have negative 1 plus I. Let's draw our diagram. So there's a diagram here. Try to plot it. We have A to be negative, so it's going to be right here, and B to be positive. So it's going to be in the second quadrant. So let's say it's right here. We draw A. So Z, negative 1 plus I. Trying to find the angle between that. So angle here is what we are trying to find, right? So the theta, if you remember the formula, we can do it easily. So theta is going to be pi plus tan inverse of B over A, where theta is going to be pi plus tan inverse of negative 1, right? So theta is going to be pi minus 45 degrees, And you know pi here is 180, so when you just subtract it, so let's say we have, so it's gonna be pi minus 45 degrees, which is gonna be 135 degrees, or 3 pi on 4 radians. Very simple. This is our answer for example 2. Let's go to example 3. So in example 3, you have the complex number z equal to -1 plus -1 minus I. So draw our diagram here. We plot it. It's going to be in the third quadrant. Let's say it's right here. Z -1 minus I. Trying to find this angle here, right? So theta here gonna be -pi plus tan inverse of b over a. So theta is equal to -pi, right, plus tan inverse of -1 over 1, which is 1. So tan inverse of negative, which is 1. Tan inverse of 1. So we have theta -pi plus 45 degrees. We know that this 180, so -180. So when we subtract, we get -135 degrees, or -3 pi on 4 radians. Very simple. Let's go to our next example. Our last example here. You can also pause the video, try to do it on your own and see how you understand it. Lastly, so we have 1 minus I. Draw your diagram here, try to plot it and see where it falls in the quadrant, because sometimes if you don't plot it, you know where it falls. So I'll draw my diagram here, plot it. I have 1 here, which is the real part A here, 1. So let's say 1 is here and -1 is here. So my diagram is going to be in the 4th quadrant, right? So finding the angle between that and that. So when you do it, you have z 1 minus I. So theta is simply tan inverse of b over a. And when you do it, you get theta tan inverse of -1. So theta is going to be -45 degrees. Very, very simple. And theta pi on 4 negative radians. Very simple. I hope you understood it. So I have some practice questions for you to do it. Try to put the answer in the comment section and I'll tell you whether you are correct or wrong, and I'll explain further for you. Thank you for watching this video. See you in my next video. Thank you. Bye.